to the Select Group's technical webinar series. We're excited to have each of you here today. My name is Lee Wallace Dodd. I'm Manager of Workforce Development here at the Select Group. As part of our experienced team, we are very excited to have JG Perrin speaking to us today on the topic of From Data to AI. JG is a longtime partner of the Select Group, an internationally recognized leader in design, development, and launching of development teams specializing in Spark. I'm going to be turning things over to him today to be speaking with you guys. At the end of the session, I will send out a recording of the webinar and also, of course, a brief link to any feedback that you have for us for future technical webinars. If anyone has questions regarding the Select Group, feel free to send me a chat individually or respond to any of my emails. I'm happy to answer them. With all that being said, I'm going to turn things over to JG. JG, thanks so much for joining us today.
Thank you so much, Lee. So it's exciting to be here today. Thank you for attending, for sacrificing your lunch break. I hope it's going to be worth it. And so let's get started. I've got a bit of material here. So briefly introducing myself. My name is Jean-Georges Perrin. I very often go by JG. It's easier for my American friends. I started building software when I was 12 years old in 1983. Doing big data, I had this crazy idea of a big data project in 1984 where it was about collecting IoT. Of course, the term was not coined at that time, but collecting IoT information from traffic lights, park meters, and all those things to make a smarter city. In college, I started doing AI a little bit in 1994. As part of my master's degree. All saying that's a past, and when I started to actually make money was 95 for software, big data. I started making money around 2006 and AI 2010. So I think we need to be all patient in a lot of things. I've one of my product achievement is to be an IBM champion. We're like 400 to 500 champions around the world. That's how IBM is recognizing as their thought leaders, their active members in their community. And I've been that for 12 years. Back, I was the first French person to be a champion. I recently started. That's the annoying thing with webinars. Like I usually ask people where they're from or trying to have some kind of mental connection with attendees, and I'm sorry we can't do that. So I live in Chapel Hill. I used to live in France, and Chapel Hill is one of the summit of the triangle area in North Carolina, and we created very recently a hub of La French Tech. La French Tech is a global organization sponsored by the French government, which means basically you get $0 or €0 to do your activities and to promote French technology in the countries where we are, or promote the local technologies in France. So it is this kind of building this bridge there, and we created a local hub in Raleigh about last year, and we got certified this a couple of months ago. So that's La French Tech, and so I'm part of the board member and the co-founders of that. You can reach me at JG Perrin on Twitter. That's fair enough and easy enough. And my blog is at jgp.ai. So you will see jgp.ai everywhere. One of the recent thing I did is I published this book with Manning called Spark in Action. It's a second edition. If you've got your camera on, you can probably see it. It's a real book. It's not only a GIF and a picture on a presentation. It's a thick book. It's about data engineering, a bit of data science in Java, Python, and Scala. I mainly talk about Java, and I'm not going to make the promo of the book. That's probably enough right now. So let's talk about AI, and I like to start any talks about AI about what's AI. Okay, what's in there for us? How do we define that? And it's actually fairly simple. There's really two kind of AI right now. There's a general AI and the narrow AI. So the general AI is all the science fiction you can imagine about AI. It's robots, it's artificial brain thinking like us. All this dystopian of movies where we're dictated by bad robots and things like that. Not saying that we're not living in a dystopia right now, but so that's general AI. And of course, we cannot. It comes to I love to mention the three laws of robotics from Isaac Asimov. And I'm just going to say the first one because I think it's the most important one. A robot may not endure a human being, or through inaction allow a human being to come to harm. So that's bringing all this ethic problems you can think of. So that's AI. Oh, I as a technologist would like to see it, but we are not there yet. We are really in what's called narrow AI, where there's a lot of mathematics, there's a lot of heavy calculation. It's based on algorithm, and the kind of exciting thing that is almost to the edge of the general AI is the self-driving cars, which made me think that we're going toward more and more general AI at some point. So just to briefly conclude on that, really these days in 2020, artificial is really a lot like machine learning. If you ever encounter someone saying that is an expert in general AI, is probably writing science fiction books and movies. Okay, so we are really, really close to all this field of machine learning, deep learning, and that's actually, we find it, I think the marketing layer on that made it probably easier to consider that as artificial intelligence. So before one of the important aspect as well of AI is what's it for? Okay, what are the benefits? What can we expect from it? And I think it's every, we're all working for businesses. Maybe some of you are more business oriented than others, but when you want to start a project, you always have to show the dollars. Okay, so I'm going to start this project because we're going to win so much dollars with it, or we're going to save so much dollars with it. That's really the thing. So if you want to start an AI project, think about explaining the benefits to your boss, which may be obvious to you, but may not be obvious to them. So it could be about new services. Okay, so new services. I've been really lucky to lead a team when I was in France in 2010 time frame, where we decided to build a new service called Voice Observer. And at that time, the idea was to measure the brand reputation. Okay, so basically, I'm doing something on the internet like. I'm leaving a digital trace of some kind. Like I'm doing this conference. Okay, so this leaves a digital trace, and what is the reputation of this digital trace? So that's something we started working on, and we had a great product for that, which was studying sentiment analysis, which is a subfield of natural language processing, or NLP. And we were doing that at scale back in 2010. It was a lot of fun. More recently, and closer to home, actually very close to home, because it's actually a startup run by a friend in Chapel Hill, a company called Lab Voice, which is basically the idea of Lab Voice is being the Alexa for labs. Okay, so you're in your lab, you're doing all your scientific experimentation, or or labs like LabCorp, like like those things with COVID-19, or just a blood sample or whatever. You Before that, they had to remove gloves or put gloves on, touch computers, and now they can just talk. They can actually call lab voice and start speaking with that. And it's not about just recording what you're saying. It's about controlling equipment, getting feedback from this equipment, etc. So that's also NLP, but combined with speech recognition, like your Alexa, Google Home, or whatever. If you're existing business, you can follow also the example of the Crédit Mutuel, which is a French bank, a major bank in France, and they started that in 2018. The idea was to be able to process more efficiently emails, and they used IBM Watson, and those days everything is called kind of Watson at IBM, but this is really about an application of Watson towards customer care, and they've managed to reduce by 50% the number of emails they had to process by day manually. So that's a pretty nice success. Another use case is AI in energy. Okay, so you can imagine that Google data centers are consuming a lot of energy, and so they one of their engineers started working with open source technology to see how we could actually predict some of the energy consumption, and based on that, they've managed to reduce their bill by 40%, which is pretty significant. Okay, and finally, as part of that, they also acquired a company that is now doing this kind of models for them. So, if we look a little bit closer at what is really under the hood, okay? So, as I've been a partner of the Select Group, as Lee said, and I'm also a software architect at Advanced Auto Parts. So I had to use a car and a car reference, okay? So as we do, okay. So let's open the hood and start looking under it. What's going on? So what can we do with AI, and how can we do it? A perception you may have is algorithm tool. Okay, so that's really the low-level stuff. Regressions, neural network, decision trees, model, notebooks, and a variety of different tools. On top of that, you've got the fields. So the fields is really where AI has a shot of doing some kind of something useful. Not the usage itself, but really the field of application. And of course, where you can use AI. So let's start by where we can use AI, because that's the easiest one. It's anywhere, okay? Anywhere. I've not seen a case where AI could not be used to partially automate some processes, to help, as we saw in energy economy, in banking, in customer service. There's always, name a case, there's always a possibility to use some AI to simplify some manual use cases. But you've got to understand which fields of AI you're going to be able to use. Okay, so and I've narrowed it down. So when you look at fields of AI, I've kind of narrowed it down to these 4 fields. And don't measure the bars by it's just a graphical effect I try to do. There's nothing like one is more important than the other. But so gaming is one. Okay. AI in gaming has been all over there. I'm still playing with Age of Empires, and they've got AI in there since forever. At this time, it was probably a lot of if and then, but it was still AI. There's computer vision. So computer vision, or CV, is really big. Okay, that's your ability to recognize patterns, recognize faces through a camera, or through fixed image, or through motion pictures. Okay. So when you're speaking about face recognition, that's a subset of computer vision. Another thing which is really important for me, and I consider it really important, is a natural language processing. And it takes many, many forms. Okay, it comes from speech recognition, as I mentioned with Alexa, or it can be for just analyzing text, as we did for Voice Observer back in time. Or now there's even a thing like there's also natural language generation, NLG, where based on the data I have, I'm making sentences for you. Okay, so that's also a subset of NLP. So NLP is really, really big. And it covers and it's segmented in many, many segments. And also, I like to add the business systems. Okay, so when I started doing AI back in college, we were talking about inference engine, system expert systems, and things like that, which I've not changed that much. You still have that ability of using more and more data. Oh, I mentioned data, and the ability of having more compute. Makes them a little bit more successful those days. So as we're going a little bit at the next layer, we can talk about algorithms as well. Okay, so there's a lot of things where you've probably done that in math in college or even high school, like linear regressions. Okay, so basically I plot a line. This is this one there. The top one, the red and straight line, where you can predict things based on values which are correlated between the axis and the ordinates, and so this is a classic prediction model. You've got logistic regression, which is kind of splitting things in parts. You've got nearest neighbors. So, for example, that's the one with the big orange and blue dots here, where you've got this yellow dot and say, hey, is this yellow dot a blue or is it an orange? Okay, when you classify things, and that's really the common algorithm you find. On top of that, you've got deep learning. So deep learning is, I would say, a subset of machine learning, focusing on trying to simulate more and more neural networks. Okay, so you've got this kind of layers architecture, where you've got this input layer, you've got subsequent layers, and you've got the output layers, which gives you your result. Okay, so those are really super CPU intensive, and that's why for those, a lot of people, to actually build the model, they use GPUs. This is typically a thing where you've all seen this kind of examples where you've got a set of pictures of cats, a set of pictures of dogs, and you give a new picture of an animal, and it says whether it's a dog or a cat. So that's where you see this kind of algorithm applied in the context of deep learning and computer vision. And you've got new stuff. Okay, so because because it's a very hot field, so you've got things which are a little bit more new. And one of the thing who made a bit of a some kind of chronicle is GAN, so Generative Adversarial Network. So this is used. This kind of algorithm are used in gaming, for example. So AlphaGo, which is the first computer to beat a Go player, by Google a few years ago, that was a GAN. Okay, things where they learn to beat you at Pac-Man, that's a GAN as well. And also a thing which I have a lot of hope for as well is reinforcement learning, and I'm trying to apply that in one of our project actually right now, and trying to make sure that the computer learns by example. You tell the computer, hey, you did good or you did bad, and based on that is correcting his perception, his attitude in doing things. So really that's AI. That's a bit of what under the hood is. But really, one of the very key thing is data. AI is not possible without data. Okay, so when I was in college a long time ago, when I started doing Lisp and Prolog, the thing is we did not have the data. We didn't have the compute, but we didn't have the data as well. So it's really about organizing your data, structuring your data, and making it so and making it available in a form you can actually use it. So sorry. So this is where I'm borrowing this this diagram from a friend of mine at IBM, Rob Thomas, and Rob is defining this as the AI ladder, and I really like the imagery of that. Where you first collect your data, then you organize it, then you can, based on that, you start analyzing, and then you can infuse that. And every time I see a ladder like that, I cannot think of anything else than Donkey Kong. So it's exactly the same way. Okay, we're going to be the Donkey Kong, and we're going through we're going to climb this ladder, Donkey Kong style. Okay, so collect. Accessing your data should be simple. That's what you need to remember. Okay, it's a subtitle of the slide, but it's really you've got to think about all the challenges about accessing data. Okay, data can be in silos somewhere. It can be in various forms. We can look at the different types of data, like transactions, log. And one type of data which is often overseen is open data. You've got all this external source of data which you can actually use, like the Census Bureau, or on a project, I've used the open data from the city of Durham with listed restaurants. Okay, so you've got a lot of data available out there, which you can find through Kaggle, through the various cities and counties open data portals. You can actually bring all this data into your projects. Okay, so that's a very rich and very important source of data. This activity here is really about gathering and storing your data so you can make it available. The next step is really organize your data. Okay, so the idea is to build really a trusted data foundation. It's mainly about building and documenting your data. Okay, you're documenting it. You're saying, hey, this data corresponds to that. And I'm probably sure that we've all seen this kind of scenarios where we've seen a field in the database and we don't know what it corresponds to. Okay, so this is this activity here. You also have to be very careful about the type of data you're using, whether it's PCI, payment card industry data, PHI, protected health information, or PII, personally identified information. You don't want this data to be available outside. Okay, you don't want to give this data to your data scientist. Oh, another word here, and that it leaks outside. Okay, so there's different processes because you don't want to remove this data. You may just want to anonymize it. Okay, so like if my health data is going through a service through an analytics system, I don't want the data science to know I'm Jean-Georges Perrin. That's my data, and that I'm slightly overweight. I'd rather have something like a John Doe associated to that, so they can still identify this data, still do the operation, but they don't have to report to me. So that's this protection activity is at this level. And you may not have to go through that, but be very careful because private, personally identified information is going easily into a lot of processes. And now there's laws in Europe. You've got the GDPR, well, I'm spacing out the name, but you've got in California, you've got the CCAP, and you've got other laws now that are protecting people from misuse of data. So that's something to be careful about. Next step is you can start analyzing, and I think this is really where the fun part starts. Okay, where you can look at the data, start discovering for data scientists and AI people start building models and rebuild them because you're never satisfied with the first one you're doing. And the outcome here is really new insight. You're starting to find things, business critical information, new ways of doing business, insights that can actually be used by your companies. And I'd like to say it's a final step. It's definitely the final step of the ladder, but it's not the final step at all. Okay, so the infuse part is really you've not reached the ground for sure, but it's really about sharing the data. And I think at that part you need to be good at storytelling. Okay, and you need to be able to take a story, bring it to your boss, bring it to your stakeholders, and tell the story. Okay, you cannot just give an Excel sheet. That's not okay anymore. But it's also where you start revising, okay, your model, because it's all live. It's if you're familiar with the PDCA, the Plan, Do, Check, Act process, you're going back. Okay, you've got to rework on your collect, on your organize, on your analyze. Okay, so that's where you are. And with smarter systems, you don't take that as analog information, but digital information, and you can actually re-inject it to build smarter apps, smarter reports, smarter everything, basically. So that's really the fourth step of the AI ladder. But whatever you're doing, it starts with an MVP, right? A minimum viable product. We're all following agile principles, and you've got to aim high, but to deliver at least very quickly. And a way to do it is to deliver a minimum viable product, an MVP. And I'd like to emphasize a lot, because sometimes MVP are prototype-like or prototype plus. But if you're doing with AI, you've got to think from the beginning on at the collect and organize part. I'm working on a search engine right now, and the search engine is not collecting enough data for me. Okay, so this is where, as we're making things smarter, we want to collect more. Okay, so collect more data, collect more meta information about who's using my search engine, what's the result are, what the query is, etc., etc. So all this needs to be collected and more, and then of course to organize that. So before you even analyze and infuse, think about having these two key steps directly in your MVP. That's what I call the AI MVP. So team. Okay, so I there are often cases where we are opposing scientists and engineers, and I'd like to spend a little bit of time on kind of going through that and understanding and explaining a little bit the difference here between the two. I used the data scientist term before. I should have defined it earlier, but let's do it now. Okay. So the data engineer is really about bringing the data in a mature industrial quality, so it can be consumed by other stakeholders. So it's about developing, building, testing, making sure the data stores are operational. You may and you will hear more and more the data ops versus as a consequence of the DevOps. So this is really the goal of the data engineer. I think one of the key thing is really the last line here. It's really about improving the data reliability and improving the data quality. I cannot emphasize enough data quality, because it sounds like it's super mega boring, but it's really something that is key to any process, especially in AI. On the other hand, the data scientist is he or she's a person who is playing with the data. They are looking at finding the insights in the data, of building predictive models, and really about finding the hidden gems and the patterns that your data may include. Okay, so and the outcome of the data scientist is really to have this story, these nice stories they can actually tell the stakeholders. So that means that the data engineer and the data scientist are using completely different tools. Okay, they're using on the engineering side, you use databases. Okay, one of my early love and still is Informix, but you've got Oracle, Postgres, MySQL. You can name them. Okay, IBM DB2, whatever. All these databases. They're also using tools like Node.js, Elastic, Hadoop eventually, clouds, plenty of things in the cloud, GitHub. This is a portfolio of the data engineer. The data scientist is using a lot of a different kind of tools. Like there's a tool called Watson Studio in the IBM portfolio. There's SAS, of course, local to us in Cary, Tableau. And you may see these two little things at the right there, down there, Jupyter and Zeppelin. Jupyter and Zeppelin are notebooks, so it's really like my class, your classroom notebooks where you take notes. But notebooks are really things like you start experimenting with. You can take notes. You can work with your code in Python, Scala, and that's kind of the cool little things you can do with notebooks. They're very super popular among data scientists. Because you can share a notebook as well. So you've got hosted version of notebooks like Databricks or IBM Watson, and or you can have them locally with Jupyter, which is open source. Zeppelin, same thing. And you can see also Excel and PowerPoint. Yeah, I don't have the last icons from Microsoft, but I think those are probably more popular because you've got the storytelling thing. Okay, so you need those tools for the storytelling part, which you may not be able to do with the other tools. And you see some common tools. Okay, you see some common tools between the two spheres. I've quickly mentioned Scala and Python, but you've got Java. Not enough. I would tend to say, being kind of a Java freak. And you also see SQL. Okay, and one of these underlying infrastructure, this underlying key component is really Apache Spark, which allows you to create this environment where data engineers and data scientists can work together and leverage powerful resources either on-premise or on the cloud. And I'm a little bit biased. That was the topic of my book, but it says nothing like Spark these days. The next slide, I borrowed this slide from a friend who's running this artificial intelligence program at Schema. So Schema is a business school which is on the NC State campus here in Raleigh, and I think it's worth mentioning that more and more schools are starting AI programs, and that's one of them. So it's worth a shot, and because it's going to be everywhere. So I also would like to mention and make sure that you get that it takes a team. Okay, I think an AI project it takes a team. You've got multiple disciplines, you've got a lot of different skills, and I've made I kind of wrote a blog post like 8-9 years after I created my first data science team, which I didn't know it was called a data science team at that time, and so this is my feedback exchange with others about how to create a team for data science and AI with not only data science outcomes, avoiding to build silos, for example. So we can do it. Okay, we've got a few minutes. We can look a little bit into code. We can drill under the hood, and release our inner nerd, I would say. So let's get it. Okay. So first, I'm going to use Java because I like Java, and I think it's a great language for doing a lot of things. You can do it in other language, and as you see, it's highly recommended to not use JavaScript. It's a very dangerous language for that, for sure. And that's where usually you love to be in a room because at least I have a future. Okay, so here's our process, and here is how we're actually going to work on that. I am I'm going to try to predict new COVID-19 cases in Italy based on the data I could collect. Okay, and I'm going to build an automated pipeline for doing that. And we're not going to cover all that in the details. I'm running a video blog, a vlog on our YouTube channel those days called DataFriday, and there's a few episodes where I'm really drilling down the various steps where I'm going into. But here, let's have at least a good overview of the process, and let's look a little bit at code. So I'm taking data. This data, I'm going to ingest that. Okay, so when I'm ingesting this data, I get what I call raw data. This is our data which is available in the system, and you can also you may see this data called staging, landing, bronze, or swamp zone. Okay, this is really the rough data you're going into. It's on your system. Then, based on that, you need to make sure that your data is worth something. So this is where you're going to apply some data quality rules. And after this process of applying data quality rules, I call this data pure data. But you can see also people call that also refinery, silver, pond, sandbox, exploration zone. Okay, so whatever. And lastly, you're going to perform some transformation, which includes analytics, which includes machine learning. And this is where you're going to get the rich data. This is a fruit of your work. This is the analytics part. This is where the data science is a little bit more used. And this zone can also be called production, gold, refined, lagoon, operationalization zone. So people have plenty of name. I like raw, pure, rich. Okay, like my coffee. Okay, so let's look at code a little bit. So here is a very basic example using Spark. So basically, is everything you're starting with Spark is create a session, and there I'm going to give it a name to my application. Say where it's going to run. And get or create a session. Okay, that's roughly it. Then I'm going to ingest the data. I go through my data purifier to apply the data quality rules, and then I can actually refine the data to get pure data for Italy, and getting my model. And from my model, I can actually predict some values. So let's collect the data. The data is freely available. Johns Hopkins University has GitHub. You can go there. I just created an automated process that is just going to fetch the data automatically, and from the data, it's going to make it locally available. So that's a simple process. Then I'm going to organize the data. Okay, in the data. So this is where it's the frustration is really. I got the data from one source. Okay, Johns Hopkins University. That's one source of the data. Every data is in one file, and it's completely frustrating. Sometimes dates are following the ISO format, sometimes not. China is either China or main China. South Korea has 3 different variants of how it's written. There is no unique ID for location, so in the first versions of the dataset. So if you want to do some kind of aggregation, you can't. And of course, files are in different encodings. Some guys would using Windows probably at some point, and the other one with Mac or Linux or whatever. This is what happened. It's rough data. Okay, so it took me about 400 lines of code of Java code to using Spark to clean up the data and to get it to where I wanted. Okay, so to create the pure data. That was covered in episode 11 of DataFriday. It's available on YouTube. So this is a bit where what I want. Okay, you see state, country, last update, the number of confirmed cases, deaths, and a combined key or unique ID, and a few other fields. In January, my data was looking like that. Okay, so I've got a province, I've got mainland China, I've got a date with U.S. time, U.S. date, but U.S. format date, but military time or 24-hour time. I've got plenty of null. At that time, the people were just getting sick. No death yet, but no recovered as well. And as the format was evolving, I got FIPS, so that's a national for the U.S. way of describing state and ID data. I've got some fields called admin2, which is basically the county, the province or state, the country or region, the last update, and you see it's still not ISO dates here. I've got latitude, longitude, etc., etc. So the data was kind of rough. The format is changing, so I've got to change that. I've got to do my cleaning process, my data quality process. After that, that's really where you release your inner data scientist. Okay, I first started to create an aggregate of the data per day on Italy. Created the model and used the model to predict. This was rough. This was shorter, but keep in mind that I'm not a data scientist. My model is really not good. But the idea was to create a rough model and to see how I can actually use it. Okay, so and that was roughly 115 lines of Java code. I added a few lately, so it's maybe 150 lines of code. There's no value here. I'm not saying, because I only did 150 that the data quality is more. But the value you get out of 100 lines of code of Java here or Python or whatever is probably more than the value of cleaning, okay, per line of code. So cleaning is expensive. Cleaning is required if you want to predict good results. And it's all about building a model, right? You've got to build a model, and to build a model, it's really about getting your data set, giving it to the trainer, and the trainer gives you the model. Then you take this model, you apply the model on your second data set, and you get predicted data. Okay. In the meanwhile, what I'm not illustrating here, you can also have test models. Okay, test data. So you can see that your model is what you expect. Okay, I didn't use test model here. Test data set. So here's my result. Okay, so what is interesting is what I'm interested in the reported date. Okay, so it's basically the date where it happens. The number of confirmed cases, the number of deaths, and I was only working on the date, on the number of confirmed cases. Death recovered, number of active, I don't care, and the day in the process. Okay, so basically, as with any of the processes, I counted the day where they had more than 5 cases, and that's actually the first day of where I took my model. And as you see in Italy, it started very quickly. And of course, the data was a confirmed number of cases, so I had also to create my new cases. Okay, so how much new cases do I have per day? Looks obvious like that. It's 62 minus 20 is 42, but you still have to do it. and you've got a feature. So basically, look what's the new column here in the features. So basically, if you look at if you look at this chart here, I borrowed from the New York Times. The label for me is a new cases. Okay, that's what you call the label. That's the data you're focusing on. That's the data you want to predict. Okay, so this is your label, and it has a set of features. In my very simplistic example here, I'm only using one feature. Okay, even if it looks between square brackets, it's because it's a vector. That's how we actually put features together. But I only have one feature, which is basically the day in the process, and that's really how I do it. One, and the prediction is that, okay, we're day one, blah blah blah. We are thick with day 140 right now, and according to this model, at day 109, at day 200, we still have 191 new cases per day. Okay, so that's my model, which is probably not that scientific. But what I wanted to illustrate is basically how you're working through it. Okay, so the small bits of code here is I'm using gradient boost regressor, and basically my GBT regressor, I'm telling it, hey, this is my label, this is my feature. How much iteration do I want? How much trees? The T actually, the GBT is tree. Do I want? What kind of loss type I want? Etc. Etc. So this parameter is often called hyperparameters. This is also where you can actually twiddle things. You can actually use a different regressor. You can, and this is how you build your model. Okay, so basically, as the first build, you build your regressor, and after that, you're training your model. So here in this situation, I give my training data to my instance of my regressor GBT, and I call the fit method. The outcome of that is model. This takes a little bit of time, and this is where I get an output of it. Okay, and my next thing is to simply use my model to predict. Okay, so once I've got my model, you see that it's super easy. I'm just calling the predict method of my model, and it gives me my result. Okay, so once more, not a data scientist. Here, the creation of the regressor and the model is super simplified. It's a bit more complex in the code, which is available in GitHub, and you can actually play with it. But it's still you get the idea. It's not that complex in terms of code. It's more complex in the term of what algorithm you're going to use, what hyperparameters you're going to use, and how you compare it with your test data. So it's really it's really the same adage all over again. It's if you got garbage in, you're going to get garbage out. Okay, so and it's even worse, because if your data coming in is even worse is bad, you can imagine the number of iterations going through the data, as those algorithms are pretty complex. The probability of getting garbage out is even higher than with a normal system. So to kind of conclude and give you a few takeaways, it's AI is a lot of math. There's no magic. Okay, it's we like to think, we humans, we like to have the wow factor, but it's really a lot of work to achieve anything there. Data quality is really a key to your success. I hope this is one of the most important takeaway, is really you've got to make sure that your data you're going to use is good. It's incredible the number of projects I've been involved in, which were called AI projects, where the data was just not in the state of quality that you need. Okay, so that's a really, really important thing. The next thing is really build a diverse team. Okay, it's not only putting a bunch of data scientists together and expecting some kind of outcome. You will, but maybe not as much as outcome as you expect. Uh, and I think also one of the other thing is do small experiments. Okay, be mindful of that. Don't start a $10 million project. Start a lot of small projects, which are $100,000 projects, or even less. You may need to work on your data qualities and that may take some of the budget, but that's still going to be useful anyway. And really be respectful of agile. I think the agile methodology really applies very well in AI projects. The way of incremental improvement, and that's really helpful. That's been helpful to me anyway. And finally, the most important one is definitely Donkey Kong is always a lot of fun. Okay, so think of the ladder and think about your Donkey Kong. So with having said that, well, thank you very much. You can join me for Data Fridays and at jdp.ai/DataFriday, and it's every Friday morning. It's going to be more and more live with more and more people getting here with guests and hosts, and we join for half an hour. So that's having said that. Please shoot the questions. Be nice. Thank you.
Thank you, JG. Looks like there's a couple of questions that have come through on the chat box. So if you want to take a look at those and then jump into some answers for those questions. If anyone else has questions, feel free to throw those into the chat as well.
Okay. Okay. All that. Okay. Question. Okay. What is the difference between AI and ML? I think I covered that a little bit at the beginning. I don't know if that was not clear enough. I don't see much of a difference. Not now. Okay, especially as you consider AI to be the narrow AI we're working on. So I don't see much of a difference. But it's marketing. We live in an industry which is dominated by marketing, and AI is definitely more sexy than machine learning. Okay, so that's really my take on it. Then some purists may find a little bit of a difference there, but it's not that much. So I think for Raghav, your question about data predictive analytics. Predictive analytics is a field. The example I used with the code is predictive analytics. It's a field. It's what I consider as part of this business systems, but it's an application within AI, like computer vision, like natural language processing. So that's how I see predictive analytics. Thomas, if I wanted to do learning on with elastic data, where would I start? And is there a good open source AI project? That's a really good question. Where do I start? Purely AI, don't buy my book. If you're interested in the first part of data engineering to bring you the correct data, that's where you need my book. But if you just want to do AI and you're good enough, there's a lot of resource out there. As you see, I wrote that for Manning. Manning is my publisher. We've got something like 20 different books on AI. If books are not your thing, we also started what we called I think it's Life Camp or something like that. I'm spacing out the name right now, but it's basically mock kind of thing, multi-user training, where you go there, you experiment, you can discuss with people. But my first experiments were really with EDX and Coursera. I think that the Manning product is a little bit better and it's also cheaper. And you've got very specific things you can target. I really like that. I really like that part. About open source AI projects, there's plenty of them. You can definitely. I don't have one on the top of my head, but Spark is open source first, and you can definitely do AI with Spark. So, and then you can find open data. I did a lot of things with open data. As I said, there's a lot of examples in the book where I used open data to achieve things and to curate the data before it can actually be used. You'll find plenty of resources there. One good website for everything data scientist is KDnuggets. I'll share that with Lee, and I'll put that so she can put that in a wrap-up email. This is a really interesting website. It's a bit complex. It's not really intro level, but it gives some insight. Yes, you can do that in Python. I'm a Java guy. I love Java. Actually, most data scientists are mostly Python people or R. And that's actually causing some problems because you've got data scientists writing stuff in Python, and you've got engineers, which I think are a bit more. I'm more towards the engineer rather than science, who are trying to productize this and put that in the chain of production, and they do all this thing in mostly. A lot of them are doing that in Java, and you've got this Python code coming in. I've worked on a project where. I didn't say that very long, but they were taking the Python code by the data scientist and rewriting it in Java for production. It's not completely stupid, but it sounds like it's a bit of waste. You've got different mindsets. Data scientists are not always engineers. They don't apply the same quality of in the codes they're writing. So having a pass through a data engineer and rewriting in Java is not always a bad thing, but there's definitely some things we can actually do better. And there's one of the Manning life camp is about putting a product out of AI, and I think that's also very interesting. John, as far as AI, would you be preferred over Python? Yeah, do Python. No, Java is not for AI. If you find a lot of resources more in Python than Java. There's also Scala. The core algorithm, okay, if as a user, okay, so yeah, to be precise in your answer, if you're a user and you want to leverage AI in your projects, Python's great. Okay, Java's great. Okay, Python is more popular, definitely for that kind of usage. So pick your scenario. If you're writing algorithm, if you're low level AI, of writing transforming this algorithm into production code, then that's C++, CUDA, because you're leveraging GPU and things like that. So this is a different set of expectation as well. Okay, users versus, I would say, developers. Ursula, can you give an example where ethics challenge in your work? How did you manage it? Fortunately, I had no ethical problems in my work, or nobody complained about my ethical problems. But a typical use case is gender, and well, actually, I had one when I worked in healthcare. We use data sets, and data sets are gender data sets. Okay, so it starts to be very difficult when you're working on data sets where you're looking at breast cancer, for example. Okay, so male can have breast cancer, but it's not as, unfortunately, popular as women. I mean, or whatever. This is what I mean. Probably come out wrong, but the thing is, this is typically kind of a bit of a gender disease, and so you've got to be careful about that when you look at this kind of data. Okay, so gender here can actually break your model, and that introduces a notion where I didn't talk about at all, which is bias. Okay, your model might be biased. If you take a population of 100 and you say, oh, out of my 100, I'm not just focusing on women for breast cancer, then you've got your data which are roughly wrong by a factor of 2. Okay, so that's one. Uh, Purely ethics is there was some cases with Amazon using using AI to filter resumes, and it's been proven that their filtering operations were bad against not in favor of women. That's a classic use case you can see in the literature as well. Not a personal case. It's like bias. You've got to look at the data. Okay, you've got to look at the data. Sometimes you've got to create data. Sometimes you've got to remove data. Sometimes people are shocked when I say you've got to create data, but there's algorithm to create data to compensate for that, and that's part of the arsenal of tools that the data scientists are familiar with. Yeah, you can have male data when you're looking at breast cancer, but you may want to remove it as well. Okay, so that's one way. Mr. Lee, as you said, dollar drives AI initiatives. How would you advise industry leaders to ensure ethics, greater goods, is also as important component of driving an AI initiative, contributing to open source, investing in startups? It's a complex. It's a complex question. It depends the company you're working in, right? Ethics and greater good is not always the goal of the company. Dollar is more often more popular than ethics and greater good. I think it's part of the ethic of the data scientist. Okay, so as I said, the models themselves are going to be probably be developed by a lot more by data scientists. They could be reused by data engineers, but and one way to look at that is to make sure that your model is being governed. Okay, so you've got things like data governance. Okay, data governance, and I've talked with people at Fidelity, for example, where they've extended their data governance to model governance, because you've got to understand that what is building your model. Okay, and because of that, you've got to make sure that your model is documented, and that's called interpretability in AI. And it's also part of this more and more laws are demanding that you be able to interpret your AI models. So that might not be greater good as the outcome of that, but it's documented. If we've got all these issues in this country about Black Lives Matter and minorities. In France, for example, where we have a law to protect citizens from data misuse since 1978, and that's probably the older part, oldest law I found in the world. You cannot store race. Okay, here you store race everywhere. So which can be good, or when you want to apply positive discrimination, but can also be bad when you see all the situations we're in. So it comes down to this being able to govern the model, make sure you know what's being used in the model, make sure that there's a real life cycle around your model, that it's not done. A model that is done is obsolete. It's a model is sufficiently of a black box that it needs to live. It needs to be re-examined on a frequent basis. So that's really where I think governance, maybe some ethical boards will be also demanding more and more interpretability in the models. I don't have examples in the company I'm working with, but I'm also not working that much with the data scientists these days. So they probably have all these things in place. I hope Sam, I answered the question. Can a really small project on AI, on either ML or AI, be done using computers without GPUs? Typical on computers, 16 gig, 1 terabyte IJ. Yeah, you can do things. It depends the complexity of the of the of the model you want to do. So, if you want to do computer vision, this might be a little slow. But if you want to do regressions, I've got roughly the same machine you're describing as my laptop, and when I'm playing with the regression model with COVID-19, it takes a few minutes for the entire pipeline to run. So yeah, it's not instant. It could be a little bit better. If I use tools probably like Jupyter, it would be a little bit more efficient. But that's because I can do replay and things like that. But yeah, it's perfectly doable with that. What you can also do is sign up for online classes. Yeah, that's a resource I forgot to mention. I think it was Thomas asking. There's a great resource called cognitiveclass.ai. I can also send the link to Lee. Cognitive Class is an IBM sponsored website where they give you training, data science training, and they give you access to the IBM cloud for playing and discovering. So you can do things. The free tier gives you enough to play a little bit with. And of course, when you do more complex stuff, you will need more resources. But to get a hand of those experiments, yeah, this is doable. And a lot of it is still data cleaning and data quality. So that's a big machine you have for data quality. Okay, Lee, I think I went through all the questions.
Yeah, thank you so much for spending a couple minutes extra time with us, JG. Thanks to all of you for joining us for our webinar today. As I mentioned at the beginning of the call, I will send out a recording this afternoon once it becomes available. Please feel free to send me any questions that you would like for me to relay over to JG. His website, LinkedIn, contact information is in the chat window if anyone needs it. Hope everyone has a great rest of their day and great rest of their week. We look forward to having you in the next in our series in August. Have a good one, guys.
Thank you so much. Bye-bye.